we go. So our unit here, what we're starting to work on today, the properties of exponents. We'll discover what they are, but then at that point it becomes, I use the word rule very lightly, but we're going to be talking about a multiplication property of exponents, division property of exponents, power to a power property of exponents. This tends to be a fan favorite, meaning a lot of students like this unit because we are working with some straightforward rules and properties that we tend to pick up on. But let's start with just terminology. Terminology gets to be very important in this unit because we're using terms that we may not have used during the year so far. So if we're raising something to a power, what does that mean? If I'm raising a number to the second power, what am I doing?
Multiplying that number by itself.
I'm multiplying it by itself. Is there another way that I could say to the second power? Like a number like this. How would you say that number? Like what is that?
3 to the second power.
3 to the second power, or what else?
3 squared.
3 squared. You could say 3 squared. How about to the third power? How else could I say that? 3. Well, I just used that number 3, but a number to the third power is a number cubed. Yeah, you can say cubed. Okay, those are just different ways you'll hear that. What does it mean to raise something to a power? If I'm raising a number, like we can talk about it here, with 3 to the second power, what does that mean? What does that mean? Because there are some common misconceptions when we talk about a number to the second power. What is 3 to the second power?
3 times
3 times 3. So you have the number 3 and you're multiplying it by itself how many times? 2 times. So our base here is 3. And then the exponent is telling you what? To multiply the base by itself that many times. So if we have a base of 4 and an exponent of 3, how can we break that out? What is that? 4 to the third is what? 4 times 4, good, times 4. Okay. And 3 squared, we've already talked about, is 3 times 3. What about 8 to the 5th? What am I doing? If I see that number, 8 to the 5th power, what am I supposed to do?
Multiply 8 5 times.
Multiply 8
By itself 5 times.
by itself 5 times. That would look like 8 times 8 times 8 times 8 times 8. And that breakout may seem silly, but we're going to use that strategy of breaking out numbers to help us learn the properties of exponents. Perfect. So what we're going to focus on today is the property of multiplying, the multiplication property of exponents, like that problem there. We have 3 to the third times 3 to the fourth. Now, it doesn't matter what the number is. What I mean by that is 3 to the third, it doesn't matter that that's 27. Right now, we don't have to focus on actually multiplying 3 times 3, which is 9, and then multiplying that times 3, which is 27. That's not what we're getting at here. What we're focusing on today is simplifying expressions that involve exponents. Okay. What do these two expressions have in common, 3 to the third and 3 to the fourth? What do they have in common? They have the same base. Good, that's key. In this scenario, they have the same base. So there is an actual property or rule that applies to this scenario. How could we rewrite 3 to the third? How would we break it out? Edgar. 3 times 3 times 3. Perfect. And how many factors of 3 did we just write? 3. Good. A direct relationship between the exponent and how many times we're multiplying 3 by itself. How about 3 to the fourth? What would that be? 3 times 3 times 3 times 3. Good. And how many factors? 4. Again, another direct relationship between the exponent, which tells us how many times to multiply a number by itself, and the number of factors we have. How can I write this entire multiplication problem by breaking it out? What would this term be written as? Again, how can I break it out? 3 times 3 times 3. And then I'm going to multiply it by this number. And what's that number broken out?
3 times 3 times 3 times 3.
How many factors of 3 do we have now? 7. So if you had to give a simplified solution, or just a simplified expression, that represents 3 to the 3rd times 3 to the 4th, what do you think it is?
You saw this.
So we have 3 times 3 times 3 times 3 times 3 times 3 times 3. So what is 3 to the 3rd times 3 to the 4th? 3 to the 7th. And how did we get the 7? Where did the 7 come from?
From the exponents.
Good. So what did I do to get that?
Oh, you multiplied 3 by itself 3 times,
Good.
and then you multiplied that by 3 multiplied by itself 4 times.
Good. So I'm really just multiplying 3 by itself how many times?
7.
7. Exactly. So this is the multiplication property of exponents. So you can write this down. Multiplication. Oh wait, is it on the next slide? Okay, yeah. The multiplication property of exponents. And the property is really the answer to this question. What is the relationship? So again, we have 3 to the 3rd times 3 to the 4th, and our simplified, I don't even want to say solution, but our simplified expression is 3 to the 7th. What's the relationship between the exponents of the two terms and the exponent of our product? So 3 to the 3rd times 3 to the 4th gives us 3 to the 7th. What's the relationship between the exponents? How do I get the 7th? Like, what's a shortcut here? Add them. So when you are multiplying, and this is the multiplication property of exponents, when you multiply same base, exponents are added together. So our example here would be 3 times 3 times 3 times 3 times 3. So that would be the example that you can write down. And the key here is your base has to be the same. It has to be the same. And you can see that breakout. So right now, at this point, we've sort of discovered the rule that if you have the same base, I could just say 3 to the 3rd times 3 to the 4th is 3 to the 7th because I added 3 and 4. But when we go through these, we're going to break them out. Like you see underneath the problem, I put like 3 times 3 times 3 times 3 times 3 times 3 times 3. We're going to start by doing that because, and I made the mistake last year, we didn't do that early on last year. We just learned the rule. And then as we started to learn the different properties, students got really confused. So we actually had to pause and take a couple of days and go back and break everything out so they could see what it actually meant. So we're not going to do that. We're going to start by breaking it out so that you can see. It may not be as essential today for you, but tomorrow when we do the division property of exponents, breaking it out is very, very helpful. And it's even more helpful when we do the power to a power property. So this is the multiplication property of exponents. And I'll cross my T so that Ms. Toll doesn't get mad at me. Does everyone have this written? Just the stuff in red. The example's really good to have. We're going to go through another example. But the idea would be just the multiplication property of exponents. When your base is the same, you can add your exponents. That would be like your shortcut. We still want to have an understanding of why that is possible, and breaking it out shows us 3 to the 3rd can be rewritten as 3 times 3 times 3. 3 to the 4th can be rewritten as 3 times 3 times 3 times 3. So really, for that entire problem, you're just multiplying 3 by itself 7 times. So we break it out, and then we simplify it back up. briefly, just take a second. It might not even take 30 seconds, but just talk very quickly about why writing out the factors would help you understand the rule. Meaning, for some of us, just remembering the rule like same base, add the exponent, 3 and 4, 7. For some of us, that may be hard to remember because there are multiple rules. But why do you think this, breaking it out, might be more helpful? Take like 30 seconds and talk about why you think breaking out might help you more than just trying to memorize a rule.
Pardon the interruption. Master Sutton to the main office, please.
Okay, so what do we think? Anyone want to share why breaking out may be more helpful? Any ideas? Is it not? Edgar, what do you think?
Some people may think that 3 to the 3rd power is like multiplying 3 times 3 instead of multiplying 3 times.
Agreed. Yeah, I think you're totally right. Some students, like when they see like 4 squared, they don't think 4 times 4, they think 4 times 2. So breaking it out proves to you that it's not 4 times 2, it's 4 times 4. That's one very helpful, and that's going to come in handy a lot, actually, in this unit. Why else might breaking it out be helpful? Specifically for the multiplication property of exponents, instead of being required to memorize if the base is the same, I just add the exponents. Because I'll tell you that, sure, we could start with that rule, and you could memorize that, but there are other rules, and I say that with air quotes because they're properties, but there are others that are similar. And what happens when you're given like a bunch of rules that you have to remember, but like some of them are kind of similar? What happens when that happens?
You get confused.
Yeah, we get confused, we might mix them up, and that's what happened last year. Because I was like, yeah, we're just going to go with the rule. And then we got to the rule, or the property, I use that word too much. We got to a different property that was very similar, and like a bomb went off in the room. Everyone was like, wait, what? Very confusing. But here, what do you see? When you break this out, what do you actually see? You're seeing 7 3s. And the operation here is multiplication. So you don't need a rule. If you know that 3 to the 3rd is actually 3 times 3 times 3, and that 3 to the 4th is 3 times 3 times 3 times 3, then breaking it out shows you that if you multiply them, you're really just multiplying 3 by itself 7 times. No rule necessary. So here, even though we say there is a rule, you're really not proving, or you're not using a rule when you do this. You're proving that you understand what an exponent does, which is really the direction we want to go. So again, in your groups, and again, this might be very quick, how does writing out the factors for that expression show you that you can't just add the exponents? We have 3 to the 5th times 4 to the 3rd. You can break it out, and then talk about how you know you can't just say, oh, exponent's 8. Take like a minute.
You can't just add the exponents because they don't have you don't add them. You just write that. So I guess, for example, for this one, they have the same base, so you can add the exponents. So it's easier to like. That's why you had to write this down. So when you multiply the same base exponent. No, when multiplying by the same base, right? 3 and the 3 are the same. You add the exponents, which is what we did before. So
What do we think?
They don't have to say.
Don't have, I'm going to play this. I want to play this. This is what I think of whenever I think of this. Why isn't it playing? This is the song I've been thinking of all day. I'm just gonna play all about that and they don't have the same base. I feel like that song's gonna just start blasting on my phone. But if you break this out, 3 times 3 times 3 times 3 times 3, you really can't simplify this any further without just calculating the multiplication. Some students will look at this like, oh, an exponent of 5, an exponent of 3, it's an exponent of 8. But the key here is that they don't have the same base. You can't just add the exponents together because that doesn't make sense. Right? Again, another reason why we like to break out the exponents or the products. Okay, so we're going to practice. But before we practice, we're going to talk about one other layer of this. And the example here would be 7x squared times 2x to the third. How would we break out that expression? Let's start with 7x squared. What is actually being raised to the second power? The x. So there's a big difference between this and this. If I were to break out this, 7x squared, what is that broken out? 7 times x times x. What's this one broken out? 7x, or 7 times x, times 7x. Very different. Okay? And this is what we shift towards at the end of the week. That's when it gets a little confusing. So let's backtrack, because we're not dealing with that one today. Unless there is a parentheses, you're not going to multiply out with that exponent. Like it's pretty clear here. How would I break out 2x to the third? 2 times. So the first thing we did here, and this is going to be your how we're going to show our work for now. We broke it out. Break out. First. Then once it's broken out, what can I do to simplify it? How can I simplify that? If I had to put it, so we broke it out, now we're going to put it all back together. What is 7x squared times 2x to the third?
14.
14. How did Rose get 14?
She multiplied 7 and 2.
Yeah, she multiplied the 7 times the 2. And what are those two numbers? What's the name of those numbers? They're the numbers right before the variable.
The base.
Coefficient. Yeah, so in this situation, if you're talking about 7x squared, what's the base? The x. The x is the base. It's being multiplied by itself, but then you're multiplying that by a coefficient of 7. The terminology comes back. So we get 14, and notice I crossed it out because when they get really big, like number 17 at the bottom, you might need to actually leave yourself some space. So we have 14. What else do we have?
The x is x. 1, 2, 3, 4, 5, 6, 7.
So x squared and x to the third. X times itself how many times?
5.
So x to the fifth.
Wait, hold on. I need to write that down. Pencil steel.
So when you're going through these examples, like the problems here, the first thing you'll do, even if you know at this point, you have written down, if the base is the same, you add the exponents. But we're not going to focus on that rule. We're going to focus on what it actually means. So you're going to break them out first. And I promise you, tomorrow, you're going to be like, oh, good thing we broke it out yesterday. Because it's going to come in handy. So first thing you'll do is break it out like we did here. Then once it's broken out, you're going to simplify it and put it back together. The only one you won't do that for is number 4. Like you could just break it out. The only way you'd simplify that besides 10 to the third is by actually calculating. Okay. So here's what we're going to do. I'm going to leave that up there for you as like a little example. You're going to start with number 4, 5, 6, 7. Number 8 is a question. It's not a calculation, it's just a question. And then 9, 10, and 12. Now here's the cool part. This is one of the Galactic Hero assignments, which you're going to have time after your DOL to do. So do these on a sheet that you would hand in as your Galactic Hero, because when you get the computers after your DOL, you can just do the rest of it hand in. All right, it's like a 2,000-point assignment.
So we do all of them on the
So there is a full assignment in Galactic Hero, and like there's a number 1, 2, and 3, and then there's a number, you know, I cut part of it so that you're already kind of halfway towards Galactic Hero. Do you want to say that? Now, do the first, so the top 4, and then the 1 question, and then those bottom 3, and then make your way to these 3, number 13, number 14, and number 17. Those are more advanced, okay, especially 17, but the idea is the same. If you break it out, you're seeing exactly what's being multiplied, and you're going to be able to successfully simplify and combine it after that.
Okay.
So while some of you may see and easily be able to, say you saw 7x squared times 2x to the third, and you knew, well, oh, x squared and x to the third is x to the fifth, and then 7 times 2 is 14. I still would like, and please do this today, break it out, because number 1, it proves that you understand what an exponent actually does. And number 2, it's going to prepare you better for the division property of exponents, which we're doing tomorrow, and the power to a power, which we'll do on Friday, and a couple of the other properties that we'll work on early next week. So I'm going to say like 15 minutes for these, but again, these are going to be, you can add to these before the end of class and submit. I already had like 5 students finish a Galactic Hero. The Galactic Hero points have been updated from Unit 4, so you can take a look if that's something that you're working towards. But when we finish this, we'll do our DOL a little early, and then you'll be able to go right to Galactic Hero. I think we'll have time. I think. Okay.
Just remember.
Give me 1 second.